One of our favorite functions out there is the parabola. In its basic form, f of x equals x squared. So let's discover what its inverse is. As you remember, replace it with a y equals x squared, interchange the variables, solve for y, and there you have it. Whoa, but some of you guys are sitting there looking at this going, wait a minute, Willie, that's not a function. It's not a function because here there are some values of x that produces two y's, and that does not define a function. So not every function has an inverse function. So in that case, what do? Well, in this case, sometimes we limit its domain to discover its inverse function. In this particular case, we can limit it to all positive values of x. So my inverse function then could be y equals the square root of x, or the inverse of x, or the inverse is the square root of x with a limited domain for only x greater than 0, or all positive values of x. And graphically, what that would look like is just that part of the graph. Now, while I'm here, I want to show you something else that you guys can use. You can use something as a horizontal line test to determine if someone has a function. So we looked at our original graph of x squared, and some of you guys are visualizing that in your head right now. There's a basic graph of an x squared. And if you look at that, I can draw a horizontal line, and when I do that, I cross the graph at two places. Because I can do that, that tells me that this graph or this function does not have an inverse function. And so sometimes I can employ a horizontal line test to determine if a function has an inverse. We're also going to discover in some of the problems today that you're looking at that inverse functions and the original functions, there's a line of symmetry between the two of them. The line y equals x produces a line of symmetry. So if I had looked at my x squared function, but if I only looked at the positive values of it, not these over here, but only the positive values of it, I can see that its inverse function is symmetrical about the line y equals x. So in this particular problem, we discovered that not all functions have inverse functions. When that's the case, we can still proceed if we limit its domain. We can look at original functions to see if there's a horizontal line test to determine if it has a function. And then also, there's something about functions when you graph them, there's a line of symmetry about the y equals x axis that determines where the inverse function will graph towards. So as you look at your homework problems, please pay attention to that because those could be also some useful tools to help you proceed farther down the problem.